Hi everyone. Today we will look at torch.nn.CosineSimilarity. But before that, I want to say that maybe this is one of the last videos that I'll be making related to NLP. For now, I plan to shift gears to topics related to computer vision, and one of the videos that I plan to make next is torch.nn.transpose convolution. But for now, we might not be doing things related to NLP, but I plan to get back to it. And I plan to get back to NLP related topics in the future. And one of the series that I plan to make is related to numerical example on generative adversarial neural networks. Okay, so let's get started. We will look at torch.nn.CosineSimilarity, which takes in the dimension at which you make your computations, and also this parameter epsilon, which we set to this. Alright, so the formula that this module uses, that I got from the PyTorch documentation, is this: similarity something like this between, say, x1 and x2. Take the marks, this is the dot product, the marks of the multiplication of the L2 norm between x1 and x2, and epsilon. So take the multiplication of the L2 norm, and whichever is bigger between that multiplication and epsilon, this is what this multiplication is going to be divided by. So let me write the formula for both dot product, this one, and the L2 norm. So the dot product between, say, x1 and x2 is this. And the L2 norm between a tensor or maybe a vector is this: square root of the sum I from 1 to n of x I squared. Alright, so this is the dot product formula, and this is the L2 norm. Alright, we are good, right? So this module takes two inputs, and the first input and both of these inputs have to have the same dimension. So say the first input is this, maybe some embedding information of some words, and the second input is this. Again, they have to have the same dimension. So this is input 1, and input 2. Okay, and I hope you can see it. Yes, it's clear. Say this is the embedding representation of the word queen, and this is the embedding representation of the word king. This is the embedding representation of the word girl, and this is the embedding representation of the word boy. So the way it works is, if the dimension is 1, you compute the cosine similarity between queen and king, and also the cosine similarity between girl and boy. and both of these inputs have a dimension of n by e. Okay, and n is the number of words, and e is the embedding dimension. Alright, so we need to compute the cosine similarity between queen and king. Okay, so we say we take the dot product, which is 2 times 1, then 4 times 0, then add them. So 2 times 1 plus 4 times 0, then divide by the max of the multiplication of the L2 norm of the first one and the second one. So the L2 norm is 2 squared, square root of 2 squared plus 4 squared, 2 squared plus 4 squared, and the multiplication of 1 squared plus 0 squared, this one king, then epsilon, and this results in 2 divided by the max of square root of 20 and e. The max of square root of 20 and e, well, it is square root of 20. If you divide 2 divided by square root of 20, you get 0.4. Similarly, between girl and boy, you take the dot product, 3 times 2 plus 5 times 7. 3 times 2 plus 5 times 7 divided by the max of square root of the multiplication of the L2 norms, 3 squared plus 5 squared, 2 squared plus 7 squared, then e. I've done it already. It is 4 to 1 divided by the max of 4 to 1.7 and e, and this is 4 to 1 divided by 4 to 1.7, because the max of 4 to 1.7 and e is 4 to 1.7, and this is 0.9. Alright, so PyTorch will give you the a result of something like this, 0.4, 0.9, which depends on n. Yes, thanks for watching, and see you in the next videos. Again, we'll be looking at generative adversarial neural networks in the upcoming videos. Thank you.